had manufacturing in this site, this ground, for over 100 years. Back in 1916, this location was the Michigan Stamping Company. Briggs Manufacturing bought the plant in 1920. Then in 1953, that's when Chrysler Corporation came in and purchased Briggs Manufacturing and acquired the Mack property. Chrysler continued stamping on this site until the late 80s, and then there was a period of time when there was no production. From late 1991 to 1995, the Dodge Viper was produced here before it was moved to the Conner Avenue assembly plant. Then construction of Mack engine began in 1996. And in the year 2000, Mack Engine 2 was completed and produced engines until it was idled in September of 2012. Then it was in 2019 when we finished production of the engines and began retooling.
When we first started this project, it was an existing engine manufacturing site here at Mack 1. And so really we had to look at how do we fit an assembly plant onto an existing site with the challenge of having Mack 1 running production for the Pentastar engine. So with the constraints of working around production ending, moving to another facility, and then getting all of the construction done and ready really in less than 2 years to complete this entire project and be building the new vehicle, it was a huge undertaking.
Utilization of 2 existing buildings, 1 new one added, and now we have a fully functional assembly plant. It's quite amazing. Plant manager.
And I'm Casey Fiddler, UAW Local 51 President.
We're here at the all-new Detroit Assembly Complex Mack.
Welcome. We'd like to give you a tour.
Come on with us.
This building is our General Assembly building. This is toward our front end process. You're right at about 1 million square feet here in General Assembly alone. We run a 3-shift operation with 670 processes.
There's roughly 770 trucks that come in per day. There's roughly 5,000 parts. All of the parts will arrive at one of our 88 docks. A portion of it is bulk and a portion of it is sequence. And they're automatically unloaded from a trailer via a robot and delivered to the operator for installation inside the vehicle in sequence. We don't want any defects reaching our customer. So we have error mistake proofing throughout the entire plant at several of the operations to aid the operator, but most importantly, protect the customer so we know that they're getting the right components and especially the safety ones.
General Assembly broken out into trim, chassis, and final. In trim, the key components are your sunroof install, your wiring harness, your instrument panel install, quarter glass, as well as windshield and back glass.
Currently we're in General Assembly Trim 1. It's the first automation cell inside General Assembly. Within this automation station, they're installing auxiliary battery for some of the autonomous features. That battery is going to be installed in the tub that's being installed with this robot. And then these operators are secondary securing it due to the trail rated features on the car.
As it goes from trim, it also then starts to merge in with chassis. In chassis, we start with the engine at our engine pedestal line and then our dress line. And then we move that over to our carding system on chassis 1. And then we finish up the underbody. And then we marry the two together, the body and the chassis. And then it goes over into chassis 2, where you're essentially connecting your major hoses for coolants, lines for AC, as well as your major electrical connections that go from the chassis to the body. It then transfers over into final assembly, which are your seats and some more of your major components. And then we hang the doors on final 2, and then put the wheels and tires on, and then it goes for final Huntsville electrical test. There, we're just testing to make sure all the connections are there. Then it goes to rolls to test all the functionality. After that, it then goes for a trip through our BSR test track.
BSR, bus squeak and rattle, as we take the vehicle from start to finish to help prevent BSRs from hitting the customer. So 100% of our vehicles get taken on the test track every day. The track is around 2,000 feet from start to finish. There's 11 different elements on the track, anything from a speed bump to gravel to patch pavement. It takes about 3 minutes for the entire process for each vehicle. This is our shaker. This is where we do additional validation beyond the BSR test track. In addition, we also use the Chelsea proving ground profiles that are a little more aggressive and that'll catch issues we just don't catch on our BSR test track.
And then if successful, it proceeds on to our inline water test.
This test has sprays that are 360 degrees all around the vehicle, including the underbody. We test 100% of our vehicles through here. It's a 3-minute test, 30 PSI. There's 600 nozzles in there, and we're just checking for any water intrusion into the interior of the vehicle.
After water test, it then comes to the certification line for final certification. When you take a look at what the customer feels, sees, and uses, it's all done here in General Assembly.
To give you some highlights of our facility, it's just under 800,000 square foot. There are 5 floors. It's about a 12-hour process from the beginning to the end. The paint shop process primarily comes from body in white. The car is in white metal. It goes through phosphate e-coat, putting the first layer of corrosion protection on.
We're at Electrocoat. This is e-coat stage 1. This paint that is electrochemically applied through our 87 anodes that are in the tank that's charged by the DC rectifier. Well, it charges the paint to the car, the unit that's present in there. You got about a 3 to 5 minute dwell time through the system.
Then we go down to sealer, where we're sealing the cars.
So we use sealer anywhere that there's an edge or an overlap of sheet metal to prevent leaks or rust or vibration, anything that would allow water to get in or outside of the body. Sealer automation consists of 28 robots in total. There's 22 sealing robots and then 6 overhead robots that open the lift gates and the hoods.
Then we put our prime layer on, our base, and our clear.
Primer is basically right in the middle of the entire paint shop. Having a nice even layer of primer on there allows our base coat to adhere to something that's nice and smooth and flat. And then that durability protection is important for the long-term viability of our products. In this booth, we have 8 robots. 6 of them are always functioning at a time. Well, all 6 of them put paint on 100% of our cars. So every single one of our cars that goes through the booth gets this gray primer on it. Further downstream, we have our 2-tone booth, which puts our black roof monocoat on the car. About 40% of our cars will have that black monotone roof. Following that 2-tone process, the cars go through an oven where those paints are cured before getting painted with our base coats and clear coats.
We are in the top coat area of paint. We are at base coat 2. So it goes through a dehydration zone. So what happens there is it removes all of the water and solvent from the paint. It then goes into the clear coat zone, which applies the final protective coating to the surface of the vehicle. The final step is the oven, and that's after clear coat. So they cure, and when they come out, they're ready to go outside.
And we come to the end product where we finesse and polish it out.
So this is our finesse department. So the cars come into the station, way down there at station 300, which is our seek and find station. Then after that, it leaves through that station. Then the employees behind that will then have a sander with 3,000 grit sandpaper, deionized water, and they're removing any imperfections on the car. As they move through the station, then you have auditors sitting here looking at it to make sure that everything is perfect on this vehicle. And this department is the guarantee when that vehicle leaves this building, our paint shop, state-of-the-art paint shop, that you have the best paint job in the world.
Body shop is where you build the foundation. This is the foundation for every single General Assembly plant. We build to the 10th of the mil. Our dimensional integrity is very critical to the rest of the process. You build a rigid steel structure and you send it to paint shop. This body shop here is like around 650,000 square feet. There's more than 500 employees work in this body shop between hourly and salary. From start to finish, it's around 2 hours.
We have our critical suppliers send in hundreds of parts for us to assess. So we measure each part individually, and then we have multiple fixtures to simulate the entire build process for the body and weight.
After we put the roof on the vehicle, we go into our laser braze booth. It's a laser beam, melts metal from the front of the roof all the way to the back. In the past, you may have seen cars that had a black strip going across the roof. On this, it's an actual finished bead of weld going all the way from the front to the back, and then it does a brush and grind. It looks like one smooth piece of metal. This gives us a very high quality finish. So it's in a laser braze booth about 80 seconds.
This is one of our 10 inspection stations we do for our weld integrity for the body shop. So as we weld in the different processes throughout the plant here, we have these stations set up. Our operators are using ultrasonic weld inspection equipment. It's very similar to what you'd use at a doctor to get your shoulder ultrasound. So the ultrasonic inspection is verifying the integrity of the weld. We want to make sure the welds are holding. So this is the body white nearline laser radar system. It's a radar technology that's mounted onto our robots. Whatever they can see, they can measure. So they're pre-programmed. We have hundreds of points near features in the car, surface points, as well as alignment points, shock towers. We want to see how the alignment goes in the front of the plant. And this complements our inline system, which takes 100% measurements. It takes about 45 minutes to complete the whole program. And we run this continually in all 3 shifts.
This is our net form and pierce line. It is just as it sounds. We do a net form. We form pads on the vehicle, and then we pierce it. The pads that we form are to create the best fit for our fenders, doors, liftgate, and hood. We should have a certain limited gap on every door, and the lines should be very symmetrical. So right now in the station in front of us, the robots, we're actually doing a measurement of the vehicle, making sure that all of our finish, our fits are perfect for this vehicle.
So we're currently standing on our panel line. This is where we assemble the doors and the hoods and the fenders to the car. This is where you actually get to see it coming together and become the vehicle that you're going to drive on the road. So we sub-assemble the doors on the 4 lines that flank the panel line, and we build the fenders as well, and then they all get installed onto the car here through our production operators. We actually take the inner door from Jefferson North, as well as the outer that comes from our Sterling stamping plant. We marry them together in our cells, and then we install them on the doors. So once the cars are assembled here, it goes to our metal finish and fit line, and they ensure that everything is nicely put together, that it's all within specifications, and that it's ready to go to assembly and be built up. So we have 15 operators and 15 stations on this line between the left and the right side.